It's an inescapable fact of life that there will always be some uncertainty in any measurement you make. And whenever you do an experiment, there will be some errors introduced that mean the value you measure is not the true value of the object. Now, these errors are broadly classified into random and systematic errors. And good experimental design will attempt to minimize these as much as possible and get results that are as precise and accurate as possible. Now we're going to go through and explain all of these terms in a bit more detail. Random errors are due to things that change a bit each time you make the measurement, whereas systematic errors remain the same each time you repeat an experiment. So let's go back to my system for measuring someone's height and think about what sort of errors might come into this experiment. First of all, the person being measured might not stand the same way each time. And then the person doing the measurement might not balance the ruler perfectly horizontal, or maybe they hold the measuring tape not quite vertical, or even not flush against the floor. So these things are all examples of random errors. Now, what about systematic errors? Maybe the measuring tape has had its end bent off so that the counting starts at 1/2 centimetre instead of 0. Or maybe it's an old plastic measuring tape that's been stretched out of shape and the centimetre marks are no longer really 1 centimetre long. Random errors tend to fluctuate around the true value, so one way to reduce random error is to repeat a measurement many times and then take an average of those values. Now, many small random errors will cancel out overall. Systematic errors, on the other hand, can sometimes be difficult to identify. One approach is to use different measuring instruments, or you can check your measuring instrument against a known object. And this process is called calibration. Next, we're going to go through the scientific usage of the words accurate and precise. In everyday language, these are used to mean the same thing, but scientists make a careful distinction between the two. The statement that Australia is in the southern hemisphere is accurate, but not very precise. But if I say Australia is centered on the South Pole, then I'm being very precise, but not at all accurate. As we've just discussed, when you repeat a measurement many times and use different equipment or methods, you'll probably get some variation in the values due to random and systematic errors. Now, if there's a small spread of values with a small amount of measurement uncertainty, we're going to call these measurements precise. If we take the average of all the measurements and find that it's close to the true value, then we say the result is accurate. Now, precision and accuracy are not the same thing. It's possible to have experiments that are very precise but not accurate, and others that have low precision but where the average of many measurements is spot on the true value. Now, you might notice that accuracy and precision are closely related to the presence of systematic and random errors. An experimental setup that has significant systematic error won't give accurate results. And similarly, large variations in measurements due to random error will mean the results are not precise.